Hey everyone, this is Mayur. Welcome to ML Works. In this video, we'll be exploring a library called cuda data frame, which is part of RapidsAI framework. And the key highlight of this particular library is it requires GPU to run your tasks. Okay, the key idea behind this is consider you have Pandas library or any other library which you use for data manipulation. So what happens in the basically is in the back end, whatever operations we do, like for instance, identifying a particular column or particular record from your data frame. Okay, so these libraries utilizes CPU cores to manipulate your work or manipulate your job. Okay, so basically what we do is with cuda data frame is we try to utilize GPUs to manipulate the same task. Since GPU has thousands of cores, basically compared to CPU cores, which are around two to dual core, quad core, or octa cores. Okay, the things that run in CUDA data frame is much faster compared to what is run by Pandas library on CPU cores. Okay, so basically the basic requirement for this whole task is that you should have one GPU in your place in your system. So consider for this what we are doing is we are currently running this notebook on Colab, Google Colab, which provides you a Tesla T4 NVIDIA GPU, and we'll check that. Okay, so first we have it here. We'll just check that NVIDIA SMI and get the details of our GPU. This is around 16 GB of VRAM, and it is currently not utilized. Okay, so what we'll do is for corresponding to this particular GPU, there is a particular version of RapidsAI that needs to be compatible. Okay, so what we'll do is we have to just clone the repository of RapidsAI, and correspondingly we have to install this pip install.py, and automatically the corresponding packages of cuDF, which is data frame, and similarly there are other libraries like cuda machine learning, cuda graph, and others. Okay, to for specific purposes. So why do we have to do this actually? Why do we need a separate library for data manipulation, right? So to understand that, then we have to look at this particular image where you can see for join operation with cuDF, we are able to do some basic or manipulation jobs like joining some data frames, okay, in 1.9 seconds, and same set of operations requires 336 seconds in Pandas. And similarly in other libraries you can see the graph. And similarly for this is for join operation or group by operation, advanced group by operations, the cuDF dot pandas takes around 5.6 seconds, and the same operation in Pandas it takes around 280 seconds, and other libraries we can see it here. So basically, when you want to increase the time or reduce the time required for doing data manipulation or any data related task, you can go ahead and use Rapids AI's other different libraries to run your task on GPUs, because GPUs has tons of cores compared against CPU. Okay, so we have already installed this library in this notebook. Okay, and we'll check those versions here. So we'll be looking at this is 23.12.01, 23.12.00. So similarly, we'll have a bunch of different versions we'll be getting for each of those library packages. Now, as part of this notebook, what we'll do is we'll try to understand how to perform basic operations on GPUs, okay, data manipulation operation, and also we'll also have something called as DASK, cuDF, which is DASK is nothing but distributed computing framework, where if you have multiple machines or multiple cores in your machine, you can utilize them efficiently by spreading your task across cores or across machines. Okay, so what we'll do here is we'll compare it first. We'll try to run the task on GPU using cuDF, and we'll also try to run the same using dask cuDF. Okay, it is like for example, cuDF is for GPU, single GPU. Okay, you can consider like that, and dask cuDF is you have multiple GPUs, then you can efficiently utilize multiple GPUs using dask cuDF. Now what we'll do is first we'll import the packages. We have cpy, and then we have pandas, then we have cuda.df, then we have dask cuda.df, and we'll have some random seed generated here. And here we'll create cuda.df.series, which is similar to pandas series. So it's of type int64 by default. Now here we have dask.cuda.df, which we can, if you see here, we have created a series using cuda.df, which can be turned into an object of dask cuda.df by using from cuda.df function, and we'll split this records into two partition. There are 5 records, we'll split it into two partition. So one thing to notice, right, in Dask, it undergoes a lazy valuation unless you don't provide dot compute on your Dask object. It won't compute anything. So we won't apply dot compute for all the tasks because it is unnecessary to do any computation unless you are doing some task. Okay, it is getting used somewhere else. Okay, so we'll just look at data here, like dot head will give, and we'll look at the data. So first what we do is from cuda.df, we'll pass the cuda.df series here. From here, we are passing it here and turn it into two partitions. And we are looking into the first 3 records. Now similarly, this is for cuda series. Now we can also create a data frame using a dictionary kind of an object, okay, which is similar to what we do in pandas as well. So one thing to notice is this cuda data frame is completely compatible with pandas API. Okay, the same functions can be utilized here. Ditto, complete one-to-one mapping is there for each functions or APIs in pandas. So here what we do is cuda.dataframe, cuda.df.dataframe. We have 3 columns A, B, C, and a range of 20, 0 to 19 value, reversed, and again same range 0 to 19, and we turn that into a data frame. Okay, here we have 3 columns now and the corresponding values present. Now again we take that and we convert that into a Dask cuda.df, and we'll just look at the head of those particular data frame. That is 5 records. Now similarly, what we can do is, this is for from cuda data frame, we are pushing it to Dask cuda data frame. Okay, now what we'll do is we'll take it from pandas, okay, and then we'll use that and cuda data frame. Okay, here this is from pandas, we are generating a data frame, and that data frame is passed to cuda.df. Just let's run this. Now again that is getting passed to Dask cuda.df. Okay, so what we understood is we can take it from pandas, turn that into cuda.df, and again then from cuda.df we can pass it to Dask cuda.df. Okay, these are like level of operations you can do, how you can segregate your data or manipulation task across from CPU to GPU, then GPU to distributed GPU. So that's how the level of complexity increases with different libraries. So here So here we have this particular, we have turned our cuda.df into Dask cuda.df. Now what we'll do is, this is our data frame, which is nothing but, if you go back, this is the data frame, which is cuda data frame. So we sort the values of those data frame using by column wise. So B is the column by which we are sorting 0 to 19. Correspondingly, all the values are sorted. A and B are also A and C are sorted. Now we can do the same here, and we can just on Dask data frame we can do the same, and we'll look at the head of this particular data frame after sorting. Now how to do what manipulation of data frame, right? We can look at records 2 to 5 of the column A and B using .loc of cuda data frame. A and B from 2 to 5 index the corresponding values. Now same thing can be done on Dask cuda.df. We need to pass .head. Now this is for by using the labels we are fetching the values. Now based on the position we are fetching the values, which is type dot ILOC, which is based on the index, which is the first value. This is nothing but cuDF, and this is also cuDF. A range of indexes are passed. So here we have 0 to 2 and 0 comma 3. This is nothing but the index, that is 0 to 3. The last value is not taken into consideration. Similarly, we have totally 3 columns A, B, C, and we are passing 0 to 2. 2 is not considered, so we just have A and B, that is 0 and 1. Now here we'll have 3 colon 5. Let's check this out. 3 and 5, 3 and 4, and 5 is ignored because last value is not taken into consideration of all the columns A, B, and C, because we are not passing any index there. If you just want index 0, then we can give it like this. It will give us the index A alone. So this is an error we are getting. I guess I have to pass dot ILOC here. So here we'll again do the same. Now what we'll do is we'll do something called as Boolean indexing, which is like if true, do a set of actions, or false, a bunch of other values are or taken out. Okay, so here we have data frame dot column B greater than 15. The corresponding whole data frame will come out. Based on that, we'll get all the values where we have B is greater than 15. There are totally 4 records. Now here we have, as we have seen in earlier step, we have 4 records. Okay, and we are passing here n is equal to 3. We'll just look at 3 records. 19, 18, and 17. Now there is also a separate keyword like query where you pass df dot query b. B is nothing but the column. Okay, and if it is equal to 3, then fetch that corresponding row or corresponding row. Yeah. Where b is equal to 3, get the corresponding row. This is a way to compute. Now if you see here, this is a task data frame and we are passing the query, and if we don't give compute, it won't execute the query. It will just wait for the dot compute module to be given, unless then it won't execute. For instance, if I don't give this one, if I just run it, you will see this is not inserting any values here. But if I do dot compute, then it will get fetch those values. Now there is also another way to perform the same set of operations using cuDF. First we are assigning a variable, a value to a variable, and then passing that to this particular query. So this is how we have to pass at cuda comparator. Same as the above query, getting the same operations. Now again we can do the same thing using for task based cuda data frame. Okay, query at val comma local dictionary. So we are creating a local dictionary where we are passing this keys value here, and then which is getting passed here at val, and then we are passing the dot compute keyword. This will give us the same results as above. And this is also one of the operations task frame cuda data frame. In column A, if values in range of 0 to 5, then fetch those values out. This is Boolean indexing, so anything between 0 and 5, okay, those values are exposed here or taken out. So this is the we have just explored the basics of cuda data frame and the task cuda data frame. So what we'll do right in the next set of videos, we'll try to compare the operation speed of these libraries, either in terms of number of GPUs or in terms of the operation taken, time taken for the operation like group by or join operations in CPU, and compare it against the GPU version of it. And we'll also compare the libraries like Dask, CUDA data frame, just CUDA data frame, or Pandas alone, or Polaris. We'll do all those such comparison and understand these libraries better. So with this, I'll just conclude this video. Thank you so much.